Jump right in here. Jump right in here. Let's see what these black holes can do. I don't know what's going on with my hair. I did just shower. Don't bully me. You know, there was an achievement. I was looking at the achievements for this game to see, you know, because we had a bunch of them, and it said pretty much all we have to do is go through the rest of these levels. We need to beat 100 levels, which is pretty much, you know, the rest of the game. But then it said you need to find a specific one of these surveyors as well, which I wonder if it pops up in World 7. But the thing is, not many people had the achievement. So I was thinking, maybe it's like hidden somewhere a little bit. Maybe it's hidden around here somewhere. Maybe it's hidden in here. But it doesn't seem to be, so I don't know. Maybe it'll pop up, we'll see. Let's jump right in. 7.1 seems to be where we're going. So this is introduction to the orientation of the velocity during a uniform circular motion. Okay. Okay. Let's go. This is one achievement. Getting the black hole generator. Black hole module installed. Very hyped. Ready to apply circular motion. Ooh. The Schwarzschild radius. To help you do a uniform circular motion using black holes, here is a diagram that shows you the direction of the velocity along the path. Sweet. Sweet. Genius. Thanks. Okay. Well, where's the black hole? It's starting in the middle. So where do we need to be? Over here, I suppose. Or, you know, 10, I guess we can do. 10. Velocity. Normally, we'd go like -5, minus... Are we going up in tens now? The velocity. Okay. And this is to 3.1 seconds. This is what we're messing with now. Now we're in 3.1 seconds. Oh dear. Let's see this. What did I do? Why am I not in 10? I'm in 0, 10. Oh, god damn. I put it myself as 10, 0, 10. Already with a messing up of my axes. Excuse me? Man, what am I doing? What am I doing? Obviously start here. Alright, well that was too much. The velocity was too much. So I don't think we need I don't think we need an X velocity at all. I think what we need is a positive Y. So we're going up here and then the black hole's pulling us in. What do you think? What do you think? Alright. Pretty easy, but 3.1 seconds. Some weird math is going on behind the scenes here that we don't want to mess with. We don't want to have to mess with. We'll leave that to Mr. LaFlamme. Introduction to the link between the centripetal acceleration, the velocity, and the radius during a uniform circular motion. That sounds super simple. No concerns. Seems like the same thing. Here's a table that will allow you to make circular movements without doing any calculations. If you prefer to do the mental calculation, you can always use... Oh my god. It's equals v squared over r. Thanks. Okay. Well, once again, we'll start at -10, 0. We can't change the initial velocity, so -15 is going to throw us down here. I think that's pretty much it, but we have to change the gravitational norm. So now we actually can mess with the black hole. What do we want it to be? So let me see. This is going from 10 to 10.5. Okay. And this is back to so 0, 10.5, 15. What? Radius of the circle. Oh, okay. So we got 15. And this is what we need to put the gravity. Yeah, obviously it goes from 1.25 to 1.67 and then to 2.5. Obviously, why would it not? And we are going at 15, so it looks like this needs to be 15 as well. Let's go. Oh. The numbers there are very freaky. What am I doing? How am I such an idiot? Go back. Obviously minus 15. You know, more than anything, it's just you need to click the button the correct amount of times. You need, more often than not, I've solved the puzzle, and I'm just like, oh, didn't click that correctly. Let's do it again, loser. Let's go. I know we got quite a lot to read, but I wanted to jump right in and play with these black hole physics because they seem a lot of fun. So of course we're gonna be positive 10 here. We've got positive 10 on the X. And it's 10, so 10 and 10. We've got 10 and 10. We want this to be 10. And there we go. Black hole physics completed just like that. We're so easy. Easy. I'm going to go get my degree tomorrow. I'm going to go pick up my degree tomorrow. No issue at all. I've got the graph. You just hand the graph in and you're done. Here's your degree. You hand the graph over, you print one of those out, and they just give you the degree. There you go. You're a scientist now. Sea of fecundity. Sea of fertility. Oh, is this not translated? Okay. Sea of fertility has a diameter of over 800 kilometers. Depending on the cultures, the patterns that the seas make on the moon have been interpreted different ways. Some cultures saw it as a man and a rabbit. That rabbit is messed up, bro, but I like it. Oh, I want that tattooed. Other cultures saw the face of a man and a woman. This is the man. This is the woman. Look how good she looks. She looks like freaking Cinderella. But the guy, this is what the guy looks like. That's so good. Brilliant. This Sea of Fertility is a great opportunity for me to present to you the 32 creators of the moon. Out of a total of more than 1,600 creators, which have been named in honor of women scientists. Let's do this. So we get to the women scientists now. That's good. There we go. Here is Hypathia of Alexandria, mathematician, astronomer, and philosopher. She founded her own academy, wrote a treatise on astronomy, commented on several classical texts, and invented several measuring instruments. We owe her, among other things, the invention of the hydrometer, an apparatus allowing measure the density of a fluid. Her father, the last director of the very famous Library of Alexandria, made sure that Hypatia received a good education, while the women of her time did not, in general, receive any. Gift in mathematics and astronomy, she surpassed her father. She is publicly accused of, by Bishop Cyril of Alexandria, of witchcraft, which would have led to her assassination by a Christian mob. Don't even get me started. This false accusation is believed to be due in part to her political power and her refusal to convert to Christianity. Her death marks the beginning of Christianity, but also the beginning of a stagnation of scientific progress when they burned all the books in the Library of Alexandria. Her life was fictionalized in the film Agora, released in 2009. I've never heard of that movie, but now I'm going to check it out. Thank you very much. This gets me riled up, man. This gets me riled up. People just want to keep living in the Dark Ages. That's just angry. Angry. Just idiots. Idiots. Blind idiots. Here is Catherine of Alexandria, or if you prefer, Saint Catherine. She's a saint, a virgin, and a Christian martyr. Okay, now we're going the exact opposite. After the Virgin Mary, she's the woman most represented by Christianity. Tradition has it that she was greatly interested in art, philosophy, and science. Today, she's considered as the ultimate promoter of philosophy, science, but also students and knowledge. There is very little historical evidence of her existence. For several modern historians, Catherine of Alexandria would be an invention of the Christian Church, greatly inspired by the life of Hypatia of Alexandria, but by reversing the roles of Christians and pagans. That is definitely what I would side with as well. Like, this is made up propaganda, basically, right? But isn't this the year? And this year is before this year. So how does that work? How's this working? 287, 360, have we got those mixed up? I have to have a look at that. What's this? Oh yeah, the circular motion of black holes. Yeah, of course they made it up. They killed her and then made up a story like, oh yeah, we love women scientists and definitely don't burn them at the stake. Here is Nicole Rain Lapout, By taking into account the gravitational disturbances due to Saturn and Jupiter, she helped calculate the exact time of the appearance of Comet Halley in March 1759. She also contributed to the writing of a treatise on horology. She also calculated with great precision the distance between the Earth, the Sun, and Venus, thanks to the observation of the passage of Venus in front of the Sun. Self-taught, she honed her skills in astronomy and mathematics thanks to the work of her husband, a watchmaker, who had to make astronomical observations and calculations in order to ensure the accuracy of the clocks of the time. Thanks to the great expertise that she developed, she was nicknamed the Learned Calculator. Her work on Comet Halley helped Alexis Clairaut published his famous comet theory, a publication that demonstrated the power of Newton's physics. Unfortunately, Mr. Clairaut did not mention the contribution of Nicole Rain-Lapointe in his publication. What a douchebag. A flower has been dedicated to her, the hydrangea. Oh, okay. Very cool. What a douchebag. Why? People suck, man. People just suck. They're just horrible. We're trying to steal credit at that point. What a total loser. You know what I feel like? I feel like this is going to be so fast. So what it's actually trying to get us to do is to start here and then come around and do a full lap, basically, in 3 seconds. What do you think? That's what I'm going to go with. I'm going to go with my gut feeling. We can't change this, so this is 5. So we've got 5, 5, 5. Oops. -5, because we're going this way, right? It's going to pull us. Let's go. I don't know why. I just feel like this is what we're doing. But it's not. I was incorrect. It was actually just totally fine. And we can just go to -5 and just go the half circle. Because the gravity is a lot slower as well. So we weren't actually trying to go faster and then get pulled in harder and have this loop, this arc here to be a lot faster. We actually just got a smaller arc. Okay, that's fine. Initial velocity then. 5. We're going to be going out here. No. 5. We're going out here and it's going to pull us around. Here we go. Do. Nice. 3.1 seconds. There's some calculations going on that are just beyond our understanding. Okay. Caroline Herschel. Here's Caroline Herschel. She's a professional astronomer who, along with her brother William, discovered thousands of new astronomical objects, including binary stars, 2 star systems, star clusters, and nebulae. Several of the nebula she discovered are, in fact, galaxies. Their existence was not yet known at the time. With her brother William and her nephew John, she's one of the instigators of the famous NGC astronomical catalogue. She discovered 8 comets, a record for a woman that was not beaten until 1980 by Caroline Shoemaker. She was the first woman to obtain a gold medal from the Astronomical Society of London. Oh, this is, 1750. She was the only one to win a gold medal until 1996, when Vera Rubin also received one. Vera Rubin made a major contribution to dark matter theory by studying the speed of stars in spiral galaxies. Her childhood was marked by illness. Her face remained marked by smallpox and typhoid, greatly hampered her growth. As an adult, she was only about 4 feet 3 inches tall. Wow. Very small. All right, we're going to go through these last 3. We can go through these last 3 before we start reading again. We can do some puzzles. So, this is the black hole. We're actually going to position it, obviously, right in the center. 10, 10, 10. It's going to be 10 itself. So, we've got we've got 10 here. We need to be going at 10 because this is 10 and we know this is 10, which means it has to be here as well. So we're going to be going at speed of 10. And from where we are right now, we can just stay where we are and go at a speed of 10 on the Y and just shoot up here and then it should pull us around. Here we go. In 6.3 seconds. Yeah, this because obviously we're covering more space than on a straight line. It's kind of funny. We're working with pi now. We're working with pi. Mary Somerville, 7.6. Let's go. All right. This is what I'm talking about. Like this, 6.3 seconds. Actually, it looks like we can just start here and go around anyway. So let's start there. We're starting on positive 10, negative 5. Black hole is going to be right in the middle at 10:10. Yep. Black hole at 10:10. And this time it's 15 and 15. So 15, 15, that's 15. And we will go at a speed of 15. There we go. Yay! Will that get that? Yes. Not that it matters because we can start, you know, any of these 4 sides basically. Alright, very nice. Very nice. Just running through this first little area here, aren't we? Just to, you know, these solutions are very clear, very obvious. 7 seconds we need to be here, so that's 8.4. So this kind of wants to be the second one that we do. So we should probably start down here. Let's go, can we go minus 30, minus 5, minus 30? Here, and then in between here and here, that is minus 5, minus 10. So minus 5, minus 10. But this time, we are going to be here. We're going to start here. So we want to go negatively into the x. I'm just going to do that. But because it's 11.25 with a radius of 5, 10, 15, 20, we've got 20. And we've got, what does it say? 11.25 here. So 20, 11.25. That means we need to be going at a speed of 15. The velocity of 15. There we go. Oh, actually, no. We should have started here. What am I doing? I've screwed myself up. What did I do? Why did I do that? We need to start at 15, negative 10. Negative 10. And we need to be going down on the y. So negative y. There we go. Sorry about that. Quick fix. 7 seconds. We only have 8.4. Alright. This one is... These ones are just easing us in, I think, and then it's just going to crush us at the last second. I'm sure of it. Luna 16. On September 20th, 1970, Luna 16 successfully landed on the moon. It was the first fully autonomous space probe to bring a lunar sample back to Earth without human intervention. The sample weighed only 100 grams. The probe stood nearly 4 meters high and weighed more than 5,500 kilograms at max fuel capacity. When it landed, it weighed roughly 1,800 kilograms. That's another modern remastering of it, basically, right? Remaking. Let's go. Mary Somerville. Her name here is Mary Somerville, nicknamed Queen of Science. Super cool. She published an enhanced English translation of Pierre Simon de Laplace's Celestial Mechanics, which remained a classical for over a century. Her book on the connection of the physical sciences was one of the best-selling science books of the 19th century. Self-taught, young Mary Somerville asked her brother to find her a book on algebra and Euclid's geometry, because at the time, women could not enter libraries. What was wrong with people, man? What is just wrong with people? Her father was opposed to her intellectual emancipation since he believed, like many people at the time, that it would affect her femininity and that mental efforts could drive her mad. I love all these emojis that he's put in the text. Her scientific curiosity was triggered by mathematical puzzles found in a magazine. That's the analog days. That was the original. That was the first space tow truck analog in a magazine. And here we are now, all these years later, with it digitalized in a video game. Here is Anne Sheepshanks. As the sole heir to her astronomer brother, she made donations totaling £12,000 sterling, the equivalent of over $1 million today. £12,000 is probably about $16,000 today. Like converting it from pounds to dollars if I had £12,000 now. But wow, going to over $1 million. Damn, yeah, pounds were very big back then. I remember my grandfather would always tell me a story that his father lost £5 on a bus. He left it on a bus because they had to run back to catch a bus, and it was kind of my granddad's fault that they were late. He needed to like get off the bus to use a bathroom when they were going somewhere, and his dad was paying for something, and then the bus was leaving. They ran away with about £5, and it was like a huge amount of money back then. That's crazy. To the University of Cambridge to promote research in astronomy, in terrestrial magnetism, and meteorology. In 1857, she was made an honorary member of the Royal Astronomical Society, an honour that only 2 other women had ever received at the time, Carolina Herschel and Mary Somerville. There's Carolina Herschel, Mary Somerville. There we go. Catherine Wolfe Bruce. Damn, what a cool name. Old Cathy Wolfe. As the wealthy heir to her father's fortune, she financially supported several astronomers in the United States and Europe, making her one of the greatest astronomical benefactors of her time. She's therefore responsible for several great advances in astronomy. She's the instigator of the Bruce Medal, a science award that recognizes each year a person whose lifelong work in astronomy has been significant. Ironically, it was not nearly a century before one woman received this award, Margaret Birdridge. We haven't seen her yet. I'm the first woman to become director of the American Astronomical Association. I wonder if we will see her. Next. So that was 7.7. Now we're going over to here, which is 12 craters approach, circular movements taking time into account. Ooh, that's the jump up in difficulty a lot we see here. Taking time into account. So now here, the 3.1 seconds nonsense. Here's a new table. About time. Oh, okay. Let's see pi. Here we go. Look at that. Pi's right there at the center of it all. We knew it was obviously to do with pi because it's the cover, you know, it's the, here we are. We've got the circumference of the circle there as well. So, of course, we're basing everything on pi. So, we are going to stay here and we can't do anything about it. The black hole is going to have to be right here, which is 15 minus 20. So, 15 minus 20. Almost got me there. Cheeky. So, 15 minus 20. We know it's the radius is 5. So, the radius is 5. And the velocity is whatever. Oh, this is the obviously the velocity of this. So, what we wanting to do? Want to put this as pi, do we? We can't do that. Can we do it as 6 point... Wait. Not as pi. What am I talking about? That's the time that we need. Oh, we have 3.1 anyway. So so we have the time, right? Which is 3.1. We have 5. This needs to be 10. So we need to be moving at 10. So we are going to start there. We need to be going at negative x at 10. And the AC here is what we need. This is time. And this is the other one. Okay, so we need to be looking at 2 charts, that's why. So radius 5 also, and then 10 here. This needs to be 20. Whoa. We sure about that? That seems crazy. That seems crazy. Let's go. Hey, we are sure about that. Look at that. Whoa. Very cool. Very cool. Because obviously pi is just the circumference of the circle, right? When it's measured as one unit. Maria Mitchell. Here is Maria Mitchell. She's the first American woman to have discovered a comet. With this discovery, she received a gold medal from the King of Denmark and was the first woman to be elected to the American Academy of Arts and Sciences. She was a teacher at one of the first institutions of higher education for women in the West. In 1873, she founded the Association for the Advancement of Women, a feminist group dedicated to promotional of equal rights for men and women. 1873, wow, very nice. In 1857, she was the first woman to be allowed to visit the Vatican Astronomical Observatory. What a badass. What a badass. Okay. 24 minutes in. I think we might be able to get through quite a couple more of these if they're, you know, keep going the way that we're going, basically. Oh, no. Well, I spoke too soon. Jesus. This seems like... I mean, it seems like hell. I see 2 circles here. In the control, you can see that the black holes must follow one another in time. You won't be able to have a black hole pause unless you choose a 0 initial gravitational acceleration. Okay, so we can change 2 black holes, yeah. Okay, so we're going to start. We'll do the big one first, right? We'll do the big one first. And we want to start at the top here, because then we want to come back to the top to do the small one. So we're going to start at 0, 15. And how long do we think that's going to be? This is so we're going to also place this black hole right in that's going to be 0, 0. And we can mess with this. Yeah, it's going up a little bit. Let's look at some calculations here. So, this first. We want the radius is 15. And our speed can also be 15, I guess. It doesn't, that's fine. And that'll be 15. So 15, 15, 15. But here, if we do 15, 15, that's 6.28. So do we do this at 6.28? So 6.3? Okay. I guess so. Wait. Yeah, 15, 15, 6.28. So we also need to be going at 15, which is going to be positively in the x direction, because we're going to be going here. So then it's going to pull us around, and then 6.28 in 2 pi, we are going to be here. What is 2 pi? What is 2 pi? If you know, you know. But we're gonna get back to here in that amount of time, and then we're gonna have to change the gravity, and we're still gonna be going. We can't change our acceleration, so we're still gonna be going 15. So now we need to be going 15 speed, but our radius has been shortened to 10. So we're here, and now it's 4.19. Huh. Surely that's not correct, because then... Well, anyway, this is going into the center here. This is going into 0, positive 5, 0, positive 5. Because the first circle's there, the second circle's there, the center of the circle. We're starting at the top. We're going 15 speed outwards, 15 meters per second. We're going out here. And that is looking 15, 15 radius is 15. We're doing that. That's correct. This is 15. That's the black hole needs to be 15, right? The first black hole needs to be 15. There we go. Okay. So the first black hole is done. But the amount of time that it's going to take, because now we're going at 15, 15, this is 6.28. This should take 6.3 seconds. Then, when we're at the top again, we have so much more time now. We almost have 9 seconds. But we can't change our acceleration or anything. So, if we're... and the radius is now 10. The radius is now 10. And our velocity is still 15. So this is 22.5. We can't do that. What's this mean? Can't do 22.5. I can only go up to 20. I think we have to go slower. So if we do the same thing, it's 15 radius, and we're going at 10. This is 6.67. Let's go at 10. The black hole is 6.67. There we go. And then if we go here, and we're going at 10, 15, 10. This is 9.42. So let's do 9.4, I guess, if we're rounding. To 9.4. I was going to say, 9.5 because we want to round up, but I'm not sure in this game. So we're just gonna round. So that one does get rounded down. And then here we have just over 6 seconds. 6.28 would do perfectly. So... we already have placed it, and we know that this one is now we're going 10, and it's a radius of 10, so this is 10, and we are still going 10, obviously. So 10, 10, 6.28, which is perfect. But this needs to be 10. 10, 10, 10. I think we've got it. Unless I've just made a silly mistake in one of my little button presses here, I think we've got it. And boom. Not so tough. Not so tough, really. we're gonna have to... You have to try harder than that, Mr. LaFlamme. To try harder than that. Let's go. That's 2 down. Let's do another one before we start reading out, because I'm loving this. Introduction to a half period during a uniform circular motion. What do you mean a half period? A half period? I mean, obviously, here's a new table. Half a turn is half the time. Oh. Oh, but it's the same but halved. Okay. You've got to fix this. You've got... This breaks my brain. This needs to be like the exact same image, but with different numbers. And it shouldn't be like everything... Like, why would the text black hole generator have to move? That's so weird to me. That's so weird. It's like it was designed differently instead of having a... It did it with this one as well. Breaks me. It breaks me inside. Just a bit of design. And then we've got quarter circles as well. Okay, so these are all the same, but quarter... This thing's what's scaring me. What's this going to be? But anyway, let's go. So we're going to start at where's this? 0, minus 10? Minus 10, 0. Sorry, minus 10, 0. Yeah, let me check. Yeah, this is the axis here, isn't it? Yeah, it's the center. Okay, we got 0, minus 10. The black hole's going to have to be here, which is minus 10, 15. So minus 10, 15. Perfect. So from that, we have the radius is 15. The radius is 15. And we have 4.7 seconds. So we need to do this. The radius is 15. This is 4.7 seconds. So we're going to be going at 10. So we're going at a speed of 10. And we're going to be going positively in the x direction out here. And I think that's it. Oh no, the gravity as well. Gravity. Here we go. We need to put in the actual gravitational pull of this thing as well. So we have a radius of 15. We're going at 10. That's got to be 6.67. There we go. Yay! Loving this game, man. Loving this game. Makes me feel so smart. I know we're doing like baby puzzles, basically, but still, feels good. It's really fun. We're only at half an hour in this video. We might be able to get through a lot more of these, but let's read up. We already read Maria Mitchell. Here's Angles Mary Clerk. She was an influential author and popularizer. She published several works in astronomy whose quality was recognized internationally. She's considered a worthy successor to Mary Somerville. In 1903, she was elected an honorary member of the Royal Astronomical Society, like Caroline Herschel and Mary Somerville before her. She shared this honor with Margaret Lindsay Huggins, one of the pioneers in the field of spectroscopy, a technique for analyzing the atomic composition of the atmosphere of stars. These people too smart, killing me. Here is Sophia Kovalevskaya, a brilliant mathematician who was, among others, one of the first women to obtain a doctorate in mathematics, to become a university professor in Europe, to be the editor of a professional journal. Couple of things, wow. At a time when women could not go to university in Russia, she decided to marry a friend so that she could study in Germany. Ha! Get wrecked! Losers, unfortunately for her. Application for admission to University of Germany was refused. No! Forcing her to take her courses unofficially. But she was still taking them, so she still got through. Carl Weierstrass, one of the great mathematicians of that time, fortunately recognized her talent and intelligence and agreed to take her under his wing by giving her private lessons. What a legend. She died of pneumonia at just 41 years old. Oh my god. Awful. Awful. She still got her education, even with a bunch of douchebags in her way. So we're going to go minus 30. Minus 30. 0. We're going to have 2 black holes. One of the black holes, they're going to be the same black hole, basically. We've just got to pull it back here. Right, so one's going to be at minus 20. And one's going to be at 0, 0. All right, well, that's perfect then. And they're going to be 3 seconds each of it. 0 to 3 and then 3 to 3. Shouldn't it be 0 to like 3.1? Because, you know, 3.14. And then like that. That seems better to me. And then let's check. Let's look. Let's consult the manual. We've got a radius of 10. And if we do... What do we actually want time first, but this is half, right? So we kind of want pi. And this is 10, 10. So perfect. That's pi. That's just right in the middle. 10, 10. So that's what we wanted. So we're going positively in the y direction. Just going to pull this back around. And then that's pretty much it. That's pretty much it, right? We're done with this. No, we need to go back here and we go 10, 10, 10. So these need to be 10. I didn't put in the pull of the black holes. 10, 10. Let's go. And boop. Very nice. Very nice. 9 out of 9. How many batteries do we have now? I remember at the beginning of the game you did like the first 5 creators and it's like, oh, you've got like 2 batteries out of 500 or something. We're getting there. We are getting there. Annie Scott Dill Russell Maunder. Wow, she was one of the first female astronomers employed in England as a calculator at the Royal Observatory of Greenwich. I know it says Greenwich, but it is Greenwich. She built a wide-angle camera that allowed her to take, at the time, the best pictures of the solar corona. She contributed to the publication of the butterfly diagram. I don't know what that is. This made it possible to show that with each solar cycle, the sunspots migrate from the pole to the equator. While graduating in 1889 with honour from Girton College, Cambridge University, she could not receive an official degree because at the time no degree could be awarded to a woman. BS. This situation did not change until 1928. Took us how many years to just not be total... I mean, I'm done with it. I'm done with it. I'm done with it. People just suck. People just suck in general. Alright, so it seems to me that what we want to do is start here, and we want to go round and round. So minus 25, 0. First black hole is going to be a little itty-bitty one right here. It's going to be minus 15. Minus 15, 0. The second one is going to be 0, 0. And we need a couple of calculations now. So, we have time, because this is a full, we want to do a full turn. So, we have 14 seconds. Let's do it. So, we have 14 seconds. This half turn with a radius of 1, 2, 3, 4, 5, 25, obviously. It says it right here. This half turn with a radius of 25 could take 7 seconds, right? 8 seconds. So we've got, let's see what that's going to do for us. This is 8 seconds. Or, 7.9. But we've only got 14. So here, if we have a radius of 10, here we go. This is perfect. So this is what we want. We want 10, 10. So we are still going at a speed of 10. So we're going to, once again, positively in the y direction from here. And this black hole is going to last... we need that to be 6... no, we want that to be 6.28. So let's do 6.3. And then we're going, because we are going 10, 10, 10... Yep, the radius of 10, 10, 10. Perfect. And then from here, we have a half turn. It's going to be this 7.85, a radius of 25. This is velocity of 10 still. So we've got 25, 10 now. 25, 10. This is going to be a gravity of 4. Let's go. I think we are absolutely dominating this one. This is no issue at all. No issue at all. The circles using pi is easy. Because pi solves everything. Here is Williamina. Horrible name, I'm sorry. Williamina Fleming. The most famous astronomer in the United States. In her time, she discovered 59 new nebulae, more than 200 variable stars, stars whose luminosity oscillates in time, and a new type of star, white dwarfs. Wow. She also developed a star classification system that provided a better understanding of the types of stars that can be observed in the sky. She led the Harvard Calculators, a group of women who revolutionized astronomy in her day. The Harvard Calculators, that's awesome. As she recently emigrated from the United States to the United States from Scotland, pregnant and abandoned by her husband, she found a job as the housekeeper at the house of Edward Pickering, the director of the Harvard Observatory. He then decides to make her work part-time as an assistant at his observatory. What a cool guy. Even though she had no scientific background, she did the job much better than the assistants who had been previously hired. After working for a few months at Harvard Observatory, she returned to Scotland to give birth and to get help from her mother. Sometime after the birth of her son, she returned to Harvard to continue her work as an assistant, leaving behind her son, whom she did not see again until 6 years later. Wow. Abandoning your son and revolutionizing science. That's what I'm. That's what I'm calling good. That's good. That's good. Bibs all over the place. Who cares? Introduction to a quarter of a period. Oh yeah. Here we go. Here we go. So we're going to be driving straight forward at a speed of 1, 2, 3, 4, 5, 6. We are gonna just going at 10. And we're going to be going at minus 30, minus 20, minus 30, minus 20. We are going to have a black hole at 0, 0. And that is going to have a radius of 18. What? No, it's going to start here. It's going to start here. What am I talking about? We have a radius of 20? 5, 10, 15, 20? No? Does it start? This is a much bigger circle. Okay, we need to look at these quarter times. This is crazy. Oh, we have 2 black holes. Oh my god, we have 2. 2. Do you need 2 for a quarter circle? What the heck is going on here? This quarter here makes me feel like this seems to be incorrect. This here, this not in the game, but I mean like this circle would obviously come out here a little bit. So this, I don't know where to place. I don't know why there's 2 black holes. I'm exiting out of this one. I want to read that again. Introduction to a quarter of a period during a uniform circular motion. During a uniform circular motion. During what the heck? Is this where it should be? No. Should still. 15, but then this goes down at 20. This is weird, man. This is super weird. Here's a new table for you. It gives you the time it takes to make a quarter of a turn while doing your circular motion. But 2 black holes? Because I was thinking if we drive here and then the gravity like grabs us and then we start pulling around, and I thought that would be the puzzle. But this seems very bizarre. 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. That's the center. We're going minus 10, 5. Minus 10, 5. Our velocity, we're going minus 30, minus 20. We are going plus 10 on the x-axis. The black hole appears here. And it's going to... The black hole, so the radius is what do we say, 5, 10, 15, 20, 25. So the radius is 25. We're going at 10, this is 4. And then quarter of a circle, here we go. So we have 25, we have 10, this is 3.93. So we need 4 seconds. That's 0 to 4, we don't know. We don't want, this isn't... Done it wrong. Well, let's just copy it. Minus 10, 5, 4. And this is nothing. There's no gravitation. We don't want this. You just be nothing. until we go 2 seconds in. Let's go 2 seconds in. And we got 3.9, which is what we need. And so this black hole, we don't want this first black hole. This black hole is what's going to pull us up here. So I think we're correct there. Let's try this out. We should be driving here. This first black hole we don't even want to exist, and then this one wants to pull us around up here. That first black hole was a trick. I knew it was. That was so weird. It confused me. It actually did kind of tilt me a little bit there. Confused me. All right. We're still going. We're still crushing it. Still absolutely crushing it. Mary Adela Blagg, self-taught and amateur astronomer, she volunteered to put order in the various lunar charts available at the time. Lunar maps she proposed, still the one we use today. Wow. She worked on variable stars, stars whose luminosity oscillates in time, in collaboration with the director of the Observatory of Oxford, Herbert Hall Turner. After this collaboration, she published her own articles about variable stars. Her passion for astronomy and her volunteer work didn't really begin until she was 45 years old. Wow. The trigger was an adult astronomy course she took at the University of Oxford. Look at that. You see, you're never too late. Never too late. Look at that. 45 years old. That's marvelous. Never too late for you to get into stuff like this. Some person who's been studying this since they were 9 years old, doesn't matter. Doesn't matter. You can still find something that you're passionate about. That's great. That's wonderful as a story. I'm gonna just quickly pause this. I'm back. Not that you would have even noticed, but let's go. Let's go. Where were we? We read Mary Adela Blagg, and now we're moving on to 7.14. Not much long this video left, but I thought we might be able to do those two things. Hey, we have a teleport here, do we? We don't have a teleport. Oh no. Oh no. In that case... Oh no, we changed position. We do have a teleport. We do have a teleport. So obviously, I'm gonna start down here. Minus 25, minus 20. Our initial velocity will be positively in the x direction. Let's just go with 10 for now. We have 12.26, and we're going to have to half that. So we have 6.3. 6.28. So that's fine. We have 6.3 and 6.3, basically. Black hole, first one's going to be here at minus 25. And that's 1, 2, 3, 4. It's 20. So we have 20 radius and 10 speed. Let's say that's 5. Oh, this is half as well. So we need 6 and 6, right? So here we go. 10. If the radius is 10, no, it's 20. 6.28, we need to be going 10. So that's totally fine. We need to be going 10, which we already did. So that's great. And then here, we know that we're going 10 speed and the radius is 20. That's 5 gravitational pull, 5 here, and 5 here. And then our next one will be... Oh, the thing is, we get to change our position, but not our velocity. So we're still going x positively. We're going this way. So that's not going to work. If we go here and we go x negatively, and we're going here, and then we teleport here, still not going to work, is it? No, we need to teleport from here. So we're going whoop, and then teleport down here. So let's go. It's 25 minus 20. The teleport. That's 25 minus 20. And that's going to be at also 6.3 seconds. And this black hole needs to be on 25.0. Okay, are we done here? Are we done here? Are we done here, is the question. We are done here. Another easy one. Another easy one. We're getting too used to the black holes. The black holes are not really that complex. We have the charts to deal with them. They're a little simple. They're a little simple to us. Let's go. Mary Proctor. Here is Mary Proctor, author, editor, and popularizer. She published 16 books on astronomy, including several dedicated to children. That's awesome. Hey, kids, you want to know how to do astronomy? You want to know how to do space science? Okay, this is 2 halves, but it's actually like 2 circles because we want to start like... I guess we want to go from... Wait a second, no. Because we're going to teleport? Yeah, we are going to teleport again. So first we're going to start here, and then we're going to go here, or whatever. Okay. Okay, that's fine. So let's start at the... We'll do the small one first, which is minus 15, 0. A velocity of positive 10 in the y direction. And let's have a look. So for half, if we have a radius of 15, 5, 10, 15, radius of 15, we have 11.6 seconds. So let's say this smaller one should be a smaller amount of time. So this 4.7 with the 10, that's 4.71. Let's do 4.7, 4.7, and then here at 4.7. And we are going to teleport then to minus 25. So that's both of our positions have been entered. Our speed has been entered, our velocity. Both the black holes we want to be in the center, so in the same place. But we need the gravitational pull now. So over here, now we're going, the velocity is 10. The radius is 15. That's 6.67. And then we have the radius of 25 with the same. That's a 4. Are we done here? Let's go. And... Oh, we did it the opposite. Oh. What am I doing? I needed to teleport on the other side. Positive 25. No, wait, what? One second. I'm going here, and then I'm going lower. Oh, of course. So this one is a little trickier. Because we can't just do that. Because we're going from here, and then we're going to go dip down. Alright, there's not much we can do about that, is there? If we do the big one first... Huh. Oh, no, this one's got me a little bit. Because now I'm thinking, where can we possibly go? We do this, because this is 15. We can actually do this as a full circle. This one we can't. So I think what we actually want to do is do this one as a full circle. So we start in the same position, and we can still be going at this velocity. Maybe we actually want to increase velocity to speed up. So we don't want to be there that long, because it's going to be a full turn now. So if we go, the radius is 15, and we're going at 15. So that's 6.28. And then here, we've got 15 and radius 15. That's 15 on here. And so what time was that? 6.28? 6.3. 2 pi. 6.3. Okay. So we're minus 15. We go over here, and then when we come back here, and then after 6.3 seconds, we teleport back to minus 25. And then we're going at 15 again. So 15 velocity, but the radius is now 25. So 9. Want this to be at 9. And then we're going half. So 25, 15, 5.24. Which seems about right. So let's go. I think we've clocked it. We've cracked it. And boom. Too good. We're too good at this. We're too good at this. Oh, we're too good at this. 10 out of 10. 10 out of 10. We're just so good. Annie Jump Cannon. Here's Annie Jump Cannon. That is not a real name. There's no way. This astronomer was part of the group of calculators of Harvard. She simplified and reorganized the star classification system proposed by Williamina Fleming. In 1925, she was the first woman to receive an honorary doctorate from the University of Oxford. Having caught scarlet fever in her childhood, she became deaf but could read lips. Oh. I really love these little factoids about all the scientists, and it's cool that there's all the women here at the end. Okay, so we're going here, and then we go here. That seems crazy. Yeah. Oh, the alarm has gone off. Give me 1 second. Back again. This is gonna have to be the last stage because dinner's ready. Let's go. So we want to let's go first. This is gonna be awkward. We have an initial position of velocity and a black hole, then we teleport and we have it again. So if we're going this way, if we swing down here, then we're going across, and then we can teleport back to here. So I think what we do is we start at -15. We have to think of the teleportation, our momentum kind of thing. So we're going at -15, 10. And our initial velocity, let's say it's going negatively y at 10. And this black hole is going to be placed here. So 5, 10, 15, 20, 25, 5, 10, 15, 20, 25. So here at 10, 10, 10, 10. And so let's have a look at this. Let's say a radius is 25. We're going at 10. That's 3.93. Let's do it as it's a quarter circle, yeah. That's 3.93. And we can 7.85, I think, is actually what we want. So we actually want this to be 5 velocity. 7.85 sounds about right. Let's say 8. And then once we do another quarter over here, and the radius is only 10, and that's 3. That's about right. Yeah, that's perfect. So we're going at 5. So this one is going to be 7.85. So let's do 7.9, 7.9. We've already got the position for it, but we don't have the gravitational pull of it, because that is, we're going at 5. The radius is 25. The gravitational is 1. And then we're going to teleport back to where we were at the beginning, which is -15, 10. -15, 10. And we're going to do that at 7.9. And from there, we want to have another black hole, and that black hole is going to be at something 20. I guess that's -15, 20. And that gravitational pull is going to be on a quarter, another quarter. That is 5 and 10, so 3.14. Oh, that's the time, sorry. Here we go. What am I doing? At 5, 10, 2.5. I think this might do it. Should swing down here, slowly, and then we'll teleport up here and swing back up here. Look at that. Purely beautiful. Beautiful science. Look at that. I'm tempted to do another level, to be honest, but I don't think I should. I think I'm going to put myself into a bad situation. I would like to finish these off, but to be honest, look how many we've done in this one video. And these are already level 8s. So I think we can crush these 2 and these 4 easily in the next video. Hopefully anyway, depending on how this is. Reviewing all the things you've learned and more. Ooh. And then there's the challenge creators, which might destroy us, to be honest. They might just kill us off. But let's go. Let's I'll call it. There's an 8th world. There's an 8th world. Is that because we've done so much? Luna 23. Luna 24. We've already... What is this? Secrets, boys. Secrets. I'm gonna have to look at I'll look at the 8th world afterwards. We're gonna read through all that anyway. We're gonna ignore it for now. But thanks for watching. I'm just loving this game. I really am. And I love now the black hole, even though it's been a little bit simpler, it's still been a lot of fun to figure out and go through the graphs, the calculations to see how we need to do it. And really, it's the puzzle of what to do with what little we have, like it was the last video as well. It's not just about the actual calculations and figuring out. I think we've got that locked in. But it's been so fun. It's been a bunch of fun. All I want to do every time, I'm just like, every day, I'm like, when can I get to play some more Space Tow Truck? And I'm coming upon the end of it now. And then I'll be writing the review up. But yeah, seriously enjoy my time with it. But thanks for watching, and I'll catch you next time. Bye.